In an astonishing twist, NASA's James Webb Space Telescope has made a groundbreaking discovery that has left astronomers around the globe amazed. Just a few weeks ago, the telescope uncovered the oldest known galaxy in the universe. However, it has now detected something even more extraordinary: a supermassive black hole speeding away from its galaxy at an astonishing 4 million miles per hour. This latest revelation is sparking important discussions and raising numerous questions among scientists and space enthusiasts regarding its implications for our understanding of the cosmos. The James Webb Space Telescope was launched with a mission to study the earliest stars and galaxies in the universe, capturing breathtaking images of stars and galaxies dying just a few 100 million years after the Big Bang. We invite you to join us as we delve into the latest findings from this remarkable telescope. If you're keen to stay informed about the latest space news, be sure to subscribe to our channel, like this video, share it to reach a wider audience, and activate the notification bell. 1 minute and 2 seconds James Webb's latest detection. This latest discovery challenges current scientific perspectives on black holes. Traditionally, black holes are seen as massive forces that draw everything, including light, toward them. However, the black hole recently observed seems to defy this norm, exhibiting behavior unlike any other known black hole. Instead of pulling in light, this black hole appears to be fostering the creation of new stars along its trail. The trail of newly formed stars extends an impressive 200,000 light-years from the black hole, baffling scientists. A team led by Yale University's Professor Peter Bond recently published their findings in the Astrophysical Journal Letters, which were later corroborated by NASA's Hubble Space Telescope. These findings suggest that the black hole triggers the formation of new stars when it interacts with gas and cools it, producing a spectacular wake of newborn stars behind it. 2 minutes and 9 seconds galactic merger detected by James Webb. But that's not the end of the story. NASA has also made an exciting announcement about a galactic merger captured by the James Webb Space Telescope. This massive merger of two galaxies can be seen glowing among other galaxies in the night sky. When two spiral galaxies collide, the event, known as ARP-220, produces a brilliant shine in the infrared spectrum, making it an ideal subject for observation by the James Webb Space Telescope. ARP-220 is classified as an ultraluminous infrared galaxy, with a luminosity equivalent to 1 trillion suns, significantly outshining the Milky Way, which has a luminosity of about 10 billion suns. Located in the constellation Serpens, approximately 250 million light-years from Earth, ARP-220 is considered the brightest of the three closest galactic collisions to us. It is listed as object number 220 in the Atlas of Peculiar Galaxies. Around 700 million years ago, the collision of two spiral galaxies triggered a massive star formation explosion, creating a dense region spanning about 5,000 light-years and containing roughly 200 large star clusters. This compact area holds as much gas as the entire Milky Way. Prior radio telescope observations have identified more than 100 supernova remnants within a span of fewer than 500 light-years. Later, the Hubble Space Telescope revealed that the two galactic cores are separated by 1,200 light-years, and each has a rotating ring of star formation emitting brilliant infrared light. The latest images from the James Webb Space Telescope highlight the spectacular galactic merger, with faint tidal tails extending from the merger edges, reflecting the gravitational pull between the two galaxies. The reddish and orange streams represent scattered organic material in ARP-220. 3 minutes and 51 seconds primordial galaxies at the edge of the universe. Another remarkable discovery has left scientists perplexed: the detection of primordial galaxies at the edge of the universe. At first, some researchers questioned their authenticity, suspecting they might simply be nearby galaxies in disguise. To confirm their findings, they shared the data with other scientists worldwide. To their amazement, the James Webb Space Telescope confirmed that these ancient galaxies are indeed real. Thanks to this revolutionary telescope, astronomers can now observe the oldest galaxies ever detected. Light from these galaxies has traveled over 13.5 billion years to reach Earth, offering a rare glimpse into the universe's distant past. These galaxies were discovered when the universe was only 350 million years old, shedding light on how rapidly the first galaxies emerged. Spectral data confirmed that these galaxies are located at the very edge of our observable universe, with some even beyond the reach of Hubble's observations. This discovery is significant as it validates one of the primary objectives of the James Webb Space Telescope: to study the early universe through light that has been journeying for more than 13.5 billion years. The telescope's ability to measure extreme redshifts allows astronomers to examine the universe's earliest galaxies in infrared, offering a deeper understanding of the cosmos. 5 minutes and 29 seconds impact on the Big Bang theory. This discovery has profoundly impacted our view of the universe, prompting NASA to consider the development of even more advanced telescopes to further explore whether our understanding of the Big Bang theory is accurate. Data from the Webb spectrometer and near-infrared camera has revealed that 4 of the 6 primordial galaxies detected exhibit extreme redshifts, suggesting that the Webb telescope is observing them as they appeared 300 to 500 million years after the Big Bang. Lacking heavy elements like carbon, this is astonishing, as the universe is thought to be 13.8 billion years old, and the existence of these galaxies challenges our understanding of the early universe. The discovery has led to growing concern within the scientific community, as these findings challenge the current cosmological inflation model and the Big Bang theory, which has unresolved issues such as inconsistencies with the laws of thermodynamics and a lack of clear explanation for the Big Bang's origin. Furthermore, the James Webb Space Telescope is uncovering galaxies that are almost as old as the Big Bang itself, raising fundamental questions about the universe's origins. Theoretical physicist Michio Kaku has stated that the discovery of these ancient galaxies has forced scientists to reconsider everything we thought we knew about the beginning of the universe. Previously, these galaxies were believed to be less advanced than the Milky Way. However, new findings suggest that they may be far more developed than previously thought, prompting scientists to question if the current theories regarding the universe's creation are accurate. Scientists' reactions and theories. The findings from the James Webb Space Telescope challenge our understanding of the Big Bang, placing scientists at a crossroads. In spite of these uncertainties, NASA has recently shared an intriguing update about a galaxy cluster that exists just 650 million years after the Big Bang, adding another layer of mystery to the puzzle. Astronomers have analyzed the data and concluded that this young cluster is expected to expand in size and eventually resemble the colossal Coma cluster, S1656. The location of this cluster is unique, as it lies in an area where galactic evolution is accelerating. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of 7 galaxies in this cluster, giving them confidence that these galaxies are bound together in a protocluster. To put this in perspective, NASA scientists have compared these distant galaxies to small drops of water flowing in different rivers, which will eventually merge to form a vast, powerful river. This comparison highlights the ongoing process of galactic formation. Clearly, what we once believed about the Big Bang no longer aligns with these findings. However, more data from the Webb telescope may ultimately confirm or challenge the theory. It remains to be seen whether the Big Bang did in fact occur and, if so, what triggered it. Regardless, the truth may be closer than we think, as the James Webb Space Telescope continues to unravel the mysteries of the cosmos. Each new discovery adds more depth to our understanding of the universe's origins and evolution. 9 minutes and 31 seconds future discoveries to expect. These remarkable findings prompt both excitement and caution in the scientific community. They force us to reassess the foundations of modern cosmology and challenge long-standing theories that have shaped our understanding of the universe for decades. The telescope's ability to peer further into the past than ever before is pushing the boundaries of what we know. It's clear that we are just beginning to scratch the surface of these profound revelations. With these latest discoveries, astronomers and physicists must now confront the possibility that the models we have relied upon may need significant revisions. For instance, the discovery of galaxies appearing within just a few hundred million years after the Big Bang suggests that galaxy formation occurred at a much faster rate than previously believed. This raises the intriguing question of whether the conditions that allowed such rapid growth were different from what we thought, or if there are factors we have not yet accounted for. Additionally, the James Webb Space Telescope's findings are forcing a re-evaluation of the very nature of dark matter and dark energy. These elusive forces have been a central part of our cosmological models, yet the discoveries made so far suggest that our understanding of these forces may need an overhaul. The acceleration of galactic evolution in the early universe, as observed by Webb, may indicate that dark energy played a much larger role than previously thought or that new, unknown forces could be at work. For scientists, this presents both an opportunity and a challenge. The opportunity is the potential for unprecedented discoveries that could reshape our entire understanding of the universe. The challenge is how to incorporate these new findings into the existing framework of cosmological theories. As more data pours in from the James Webb Space Telescope, astronomers will continue to refine their models and try to make sense of the new realities that are emerging. 10 minutes and 57 seconds. How this changes space exploration. The implications for future space exploration are also significant. With the James Webb Space Telescope now able to peer into the deepest reaches of space, it is providing us with an unprecedented view of galaxies, black holes, and star-forming regions that were once thought to be beyond our reach. This opens up new possibilities for future missions and technologies aimed at exploring these distant and ancient regions. For example, the discovery of galaxies that formed so early in the universe's history may lead to the development of even more advanced telescopes capable of studying the conditions that led to their formation. Moreover, these findings have the potential to influence the search for extraterrestrial life. Understanding how galaxies and stars formed in the early universe could help scientists identify the conditions under which life could emerge elsewhere in the cosmos. If life could arise so early in the universe's history, could it have appeared in other places too? These discoveries might be the key to answering that age-old question. As we continue to explore these mysteries, it's important to remember that the discoveries from the James Webb Space Telescope are not just advancing our knowledge of space, they are reshaping our understanding of time, matter, and the fundamental forces that govern the universe. With each new observation, we move closer to answering some of the most profound questions humanity has ever asked. What is the nature of the universe? How did it begin, and how will it evolve? Is there life beyond Earth? These questions may not have easy answers, but with the data coming from the James Webb Space Telescope, we are one step closer to unraveling the mysteries of the cosmos. As the telescope continues to explore the vast reaches of space, the discoveries it makes will likely continue to surprise and challenge us. The more we learn, the more we realize how much there is still to uncover. The universe is vast, and our understanding of it is still in its infancy. But with each new finding, we get a little closer to understanding the ultimate nature of reality itself. 13 minutes and 27 seconds. The future of space exploration. As we venture deeper into the cosmos through the lens of the James Webb Space Telescope, it is becoming increasingly clear that we are on the brink of a new scientific revolution. The discoveries made by Webb offer a glimpse into parts of the universe that were previously beyond our reach, providing valuable data that will influence the next generation of space exploration. One of the telescope's most profound capabilities is its ability to peer into the infrared spectrum, allowing scientists to study celestial objects that are not visible to traditional optical telescopes. This ability is crucial for studying distant and faint objects, such as the earliest galaxies and the enigmatic structures surrounding supermassive black holes. In addition to these awe-inspiring revelations, Webb's findings could potentially alter our perception of time itself. By observing galaxies that formed just a few 100 million years after the Big Bang, Webb challenges our understanding of how quickly the universe evolved. These ancient galaxies, some far larger than expected, suggest that the process of galaxy formation may have been much faster and more complex than previously thought. This raises the exciting possibility that there are still unknown cosmic forces at play, ones that we have yet to fully comprehend. Moreover, these discoveries could redefine the future of human space exploration. As Webb continues to explore galaxies at the farthest reaches of space, it will inevitably inform the development of new technologies and spacecraft capable of venturing into these regions. The newfound knowledge about the early universe may not only guide our quest to understand the origins of galaxies, but could also provide clues about the existence of life beyond Earth. 15 minutes and 30 seconds. Conclusion. In conclusion, the James Webb Space Telescope has already made remarkable strides in advancing our knowledge of the universe. From the detection of ancient galaxies to the observation of black holes with behavior unlike any seen before, the telescope is pushing the boundaries of what we thought was possible. As scientists continue to analyze the data and make new discoveries, it is clear that this is just the beginning of a new era in space exploration. The revelations from the Webb telescope promise to shape our understanding of the cosmos for years to come, and we can only imagine what the future holds as it continues its mission to explore the furthest reaches of space and time. What are your thoughts on these groundbreaking discoveries? The next era of space exploration. The discoveries made by the James Webb Space Telescope, JWST, are not just reshaping our understanding of the cosmos, they are also laying the foundation for the next era of space exploration. As we venture further into space, new questions arise. What other cosmic phenomena remain undiscovered? Could even older galaxies be hidden beyond the observable universe? Is it possible that life existed much earlier than we thought? These questions drive scientists and space agencies worldwide to develop more advanced observational tools and spacecraft capable of uncovering the deepest secrets of the universe. While the James Webb Space Telescope is currently our most powerful eye in space, its findings highlight the need for even more advanced instruments that can peer further back in time, detect even fainter signals, and perhaps even observe the first moments after the Big Bang. With each new discovery, we move closer to answering the biggest mystery of all. How did it all begin? 17 minutes, the future of space telescopes. Inspired by JWST's groundbreaking findings, NASA, ESA, and other space agencies are already planning next-generation telescopes that will complement and extend Webb's discoveries. One such mission is the Nancy Grace Roman Space Telescope, set to launch in the late 2020s. This telescope will specialize in dark energy research and help answer some of the biggest questions about the accelerating expansion of the universe. Another ambitious project is the LUVOIR, Large UV/Optical Infrared Surveyor Telescope, a potential successor to JWST that could be capable of detecting Earth-like exoplanets in unprecedented detail. Meanwhile, ground-based observatories such as the Extremely Large Telescope, ELT, in Chile and the 30-meter telescope, TMT, in Hawaii will push observational boundaries from Earth. These observatories, using adaptive optics, will be able to study exoplanet atmospheres, black hole dynamics, and distant galaxies in ways never before possible. With all these new telescopes working together, humanity is on the verge of answering some of the most profound questions in astrophysics and cosmology. But what about human space exploration? 18 minutes and 30 seconds, the future of human space travel. As our understanding of the universe grows, so too does our ambition to explore it firsthand. Scientists and engineers are now designing new spacecraft and habitats that will allow humans to travel deeper into space than ever before. Upcoming missions to the Moon and Mars. NASA's Artemis program aims to return humans to the Moon within the next few years, with a long-term goal of establishing a permanent lunar base. This lunar outpost will serve as a testing ground for technologies that will eventually allow humans to live and work on Mars. Meanwhile, SpaceX and other private companies are developing next-generation spacecraft, such as Starship, which could transport astronauts to Mars within the next decade. If successful, this mission would mark the first step toward making humanity an interplanetary species. Interstellar travel, a dream or a reality? While human missions to Mars are within reach, scientists are already thinking even further ahead, toward interstellar travel. Could we one day travel to other star systems? Currently, the fastest spacecraft ever built, Voyager 1, has taken over 45 years just to leave our solar system. At this rate, reaching the nearest star system, Alpha Centauri, would take tens of thousands of years. However, groundbreaking concepts such as nuclear propulsion, antimatter engines, and light sail technology could one day make interstellar travel a reality. One of the most exciting projects in this area is Breakthrough Starshot, an initiative aiming to send tiny, ultra-fast probes to Alpha Centauri within a human lifetime. These probes, propelled by powerful laser beams, could travel at 20% the speed of light, reaching their destination in just 20 years. While such missions are still in their early stages, they represent the beginning of humanity's journey beyond the solar system. And with JWST revealing thousands of exoplanets that could potentially harbor life, the question remains, are we alone in the universe? 20 minutes and 30 seconds, the search for extraterrestrial life. Perhaps one of the most profound implications of JWST's discoveries is the growing possibility that life exists beyond Earth. For decades, astronomers have been searching for planets that could support life. Now, with JWST's ability to analyze exoplanet atmospheres, we are closer than ever to answering this question. Potential biosignatures found? Recently, JWST detected carbon dioxide, methane, and water vapor in the atmospheres of multiple exoplanets. While not definitive proof of life, these findings suggest that some planets may have conditions suitable for biology. The search for biosignatures, gases that could be produced by living organisms, is one of the telescope's primary missions. Future observations may reveal clear evidence of biological activity in the atmospheres of distant worlds. One of the most promising targets is TRAPPIST-1, a system with 7 Earth-sized planets, some of which lie in the habitable zone, the region where liquid water can exist. If JWST or its successors detect oxygen, ozone, or complex organic molecules on one of these planets, it could be the first sign that life exists elsewhere in the cosmos. But what if intelligent life is out there? 22 minutes: the future of SETI and contacting alien civilizations. The search for extraterrestrial intelligence, SETI, has been listening for signals from alien civilizations for decades. However, despite scanning millions of stars, no confirmed signals have been detected yet. JWST's findings suggest that advanced civilizations may be rare, or they may communicate in ways we do not yet understand. Some scientists propose using JWST to look for technosignatures, evidence of alien technology, such as artificial megastructures, e.g., Dyson spheres, unusual chemical compositions in exoplanet atmospheres, unexplained bursts of infrared radiation. If we do detect a signal or evidence of an advanced civilization, it would be the most transformative discovery in human history. But what if we're looking in the wrong places? Some researchers suggest that alien life may not be based on carbon or may exist in dimensions we cannot perceive. Others speculate that extraterrestrial civilizations may be deliberately avoiding us, a concept known as the Great Silence. Whether we find life or not, the search itself is reshaping our perspective on humanity's place in the universe. 24 minutes: the beginning of a new cosmic age. As the James Webb Space Telescope continues to uncover new cosmic mysteries, we stand on the edge of a new scientific revolution. Each new discovery brings us closer to understanding the origins of the universe, the evolution of galaxies and black holes, the possibility of extraterrestrial life, the future of space exploration. With missions to the Moon, Mars, and beyond, the dream of becoming a multiplanetary civilization is closer than ever. The next few decades may answer some of the deepest questions humanity has ever asked, and perhaps pose new ones we have yet to imagine. As we look up at the night sky, one thing is certain: our journey into the cosmos is just beginning. 25 minutes and 30 seconds. What do you think? How do you think these discoveries will shape our future? Do you believe we will find life beyond Earth in our lifetime? Share your thoughts in the comments below. We would love to hear your insights.